that you can see that in how they were built. And people wonder, did they just happen to do that accidentally, or did they know about the damn thing? And think it was called golden because they thought it was related to holy stuff. They thought it was, you know. The nice thing about that is it shows up in biology. You count the number of pine cone seeds on a pine cone, and it's always going to be at some number in this sequence. You count the number of branches across on a tree, as long as nobody's cut the branches off. Most of the time it's going to be a number in this sequence. That's kind of freaky. Right? But this really just defines how nature builds on itself as they grow.
What's it called?
It's called the Fibonacci sequence.
Ooh.
Fibonacci.
Do we need to know that?
Do you need to know that? No. Do you need to be able to figure out a sequence if I give it to you? Yes. Do you have to know the name of it or the applications of it? No. But I just always give you backstory.
Arithmetic? Arithmetic?
Not arithmetic, because geometric and arithmetic are incredibly simple-minded sequences. One, you always add the same thing. The other one, you always multiply by the same thing. Arithmetic addition, geometric, you multiply.
Yeah.
This one, I'm adding elements of itself to get the next thing. That's neither one of those. I don't keep adding the same thing, right? I definitely don't keep multiplying by the same thing. It's neither one.
So the other number, 8 plus 6, 14?
No,
8
5
plus
8. 8 plus 1.
5 is 13.
Yeah.
8 plus 13 is 21.
21.
And you can keep going forever. The really weird thing is, the further you go out, if you divide 1 by the number before it, if you divide these two and you keep going further out, it's going to become 1.618, always. That's the golden ratio. It shows up in art, it shows up in black holes, it shows up in chambered nautilus shells, it shows up in holy shit. Fibonacci. Fibonacci. Okay. Sorry, that's probably a lot more than any of you guys want to know. It's really cool. If you just go, I always have my 120 students, go to Google or whatever your preferred search engine is, type in Fibonacci and then any word of something you're interested in. Fibonacci surfboard. Somebody made a surfboard that actually has curves related to the Fibonacci sequence, and he claims that it's better than a surfboard. All right. Type in Fibonacci music, type in Fibonacci space, type in Fibonacci politics, Fibonacci freaking economics. My friend Sean, he's making like 6 figures. He used to work at Dell, would meet with Dell himself every night. He's telling me about, all these, he knows tax loopholes. I'm like, shut up. So he uses, when he does his stocks, he uses the Fibonacci sequence to tell when to sell. You look at the number of peaks related to the numbers in the sequence, and it tells you when to sell, when to buy. And he made money over the years of the recession. He made money.
Really?
You just type Fibonacci stock market into a search engine. It's silly. All right, sorry, that's enough of a sidetrack. Second.
On page 85, it is different. Number 39, please.
39. Oh, this is the one I was talking about. It's a little bit different. It's not as freaky as this.
Yeah.
Do I keep adding the same thing? But what's 7 plus 1 is 8. 8 plus 2 is 10. 10 plus 3 is 13. So then I add 4.
17.
Beautiful.
Arithmetic.
So I can make a sequence. Basically, I can make a sequence any damn thing I want to. So very often I'll give you a bonus. I always give 3 bonus questions every test. One of them on this first test is going to be some freaky-ass sequence, just to see who can figure it out. Right? Sequences don't have to be mathematical either. They could be visual, they could be pictures, they could be who knows. Sorry, yeah.
It's like 99 on page 99, question 45. I couldn't figure it out.
45. Okay. And I think this is the last one, then we're going to get some new stuff here.
Page.
Page 99. Now, I know some of us, when we see a fraction, we immediately want to clear it. But let me ask you something, a little side note. If I had this, Would I want to multiply both sides by 4 to clear the fraction?
No.
Why do I not have to? I could, but I'm adding work. Because the 4 already cancels with that 4, right? Then I got the answer, x is 2. I'm done. So I don't have to multiply both sides by the LCD because look what's inside. If I distributed this through, what would happen with the 4? Wouldn't it cancel with both of those things? So no more bottom? What happens on the other side? So if you wanted to, you could multiply both sides by 12. You would just make all the numbers bigger than they really have to be because the bottoms already want to cancel.
Can you cancel them like this without making it a common denominator? Or you only do
Definitely,
that-
because I only need an LCD if I want to act with all of the fractions at once. Then I need an LCD to kind of group them together.
You can cancel
Here,
them
what I
out.
can do instead is I can have 3/4 times 8x minus 3/4 times 4. Is that cool? I just distribute that through. And then 2/3 times 6x minus 2/3 times 9. How's everybody do that? I mean, I'm just writing out the property. And you guys see how this helps me. I don't want to try and do it all at once. Now I can just focus on each thing. 4 goes into 8 twice. So here I get 6x. 4 goes into 4.
Minus 3.
Dies. Cool. Minus 3. 3 goes into 6. So I get
4x.
4x. 3 goes into 9.
3.
So I get 6. And that's easy, right? Now, if you did multiply by 12, just a little side note. If you did want to, or if you did multiply by 12, just to be careful here, because the LCD is obviously 12. If I multiply both sides by 12, we saw one like this a second ago. 12 and 4 cancel to 3. Do I still have a 12 to go in here? That's what people always make a mistake. They multiply the 12 by both. You're not distributing. This is already multiplication. So when 12 dies here, it's gone. It's become a 3 now. 3 times 3 is 9. And this stays the same. And 3 goes into 12. 4 times 2 is 8. And this stuff stays the same. And then you keep working. You'll eventually get to the same place you would get here, just with larger numbers, right? So either way, fine. Just don't kill your fractions if they already want to die. Very violent math that
Then
teach.
you multiply it, it would be 72x minus 4, right?
Exactly. Well, careful. 72x minus.
Minus 36.
Yes, cool.
Okay.
And distribute your.
What I'm saying is you just multiply both sides.
Exactly. Multiply, do each side. Get your x's on one
Can I
side.
ask a question? Can you, instead of putting 12 on top, could you multiply both ends to by 3 and make it 9 12ths?
No, if you multiply by 3, it'll be 9/4. Because
Oh,
3
it's
is
4.
3 over
Okay.
1.
What I'm, okay.
Okay. And then you could make this 9/12ths and make this 8/12ths. When you multiply by 12, then you have a 9 left and an 8 left.
So
Right,
x
that's fine.
equal to -2/3 left.
جواب ناقص
Yeah, 2x, negative 3 halves.
هالجزء
Yeah. How's that, guys? All right, so now we're going to get into section 2.2, and then we're going to get into word problems.
Professor, I know this is probably
No, no.
really important.
105.
Don't sell yourself short before you ask.
I really do get lost in the science review. If you could just humor me and just tell me when you each one of them.
Oh, if you ask me, I'll remember, but I'm not going to make a general announcement. But today, I think we're going to do 2.2 and 2.3. Then those will be due when?
Next
Monday.
Next Monday. 2 class periods later. If you're not done with it, it's not the end of the world. You have until the day of the test. But that kind of tells you you're about on track. Oh, right? Is that cool? The dates on this are just the days I think we'll be talking about these chapters. Doesn't really have anything to do with due dates.
Okay, so let's start with 215 on this one.
Look at
This is what you're saying, that you go from 15, and then every fifth one, so it's 1, 2, 3, 4, 5. Okay, so I'm just
Yeah,
going,
every-
okay.
So 15, 20, 25, 30, just count by 5.
Okay,
Each have the same.
because
Yeah,
on the last assignment, I did every one. That's why it took me forever.
Yes, lots of practice, but thank you for
I'm
that.
gonna tell you something on my notes. I did one page like the other one, so it matched.
Okay.
I flipped the page.
If I get mad, I'll just internalize it.
Okay.
Save it for when I'm grading too. All right. So you guys picked up on it. The very first part of section 2.2 should be easy. I don't feel bad saying that. Let me give you a couple examples, and then we'll get into the freakier part. So here's what I mean. If they give you R equals that, 900 minus 300 times P, all of that times P. And they tell you, find R if P is 1.5. Well, that
You plug
is
in-
easy.
You plug in
Right.
1.5 for P.
Yeah, you know what P is. They're giving you a value for P, which is the whole point of this, right? Whenever I have letters in an equation, that just means I don't know them yet. Somebody's got to tell me. And it makes sense. If I'm doing physics, and when I crank the energy up, what's going to happen over here? I got to have a place to plug the new energy in to see am I going to explode something or no? I'd rather not. So before I crank it up, let me put in an equation to make sure it's safe, right? So here I got this equation. Well, what if we made P equal 1.5? What do you do? 11. Just plug it in.
Yeah,
Right.
and then you'd have it on the back end too.
Exactly. Wherever you see a P, 300 times 1.5, all of that times 1.5.
but the 900 is not multiplied with P.
Not with that P, but that P, yeah. So
No,
just do order
900.
operations.
What's 900?
That 900 is not being multiplied by any P yet. Whatever this number is here then gets multiplied by P. If you wanted to, could you distribute this through? Hell yes, right? Of course. You could do any simplification you want to before you plug things in for values. Just make sure the simplifications you're doing are legal. So if I wanted to, I could distribute the P in and then plug P in after that. But how do you do this? What's order operations say?
Do the parentheses first.
Inside here,
So it has to be multiplications first.
multiplication before subtraction.
450.
Okay.
Yeah, that was 450.
Now I've got subtraction in here times this. Of course,
675.
I got to do in the parentheses first,
Right.
right?
That's 450.
450 times 1.5,
675.
675, 11. Right? So that should be easy. I don't mind saying that. If it's not easy, come see me. Because plugging things in for variables, that should be like, oh, please, Jeff, give me more and more of those.
Yes.
Like everything that. Yay. Is everything going to be that? No. All right. And they really don't get any freakier. I mean, they'll give you some polynomial stuff here. Like, for example, oh, if x equals, let's say, yeah, plug and jump. Right.
So you're going to plug in 2 for the x.
Exactly. Every x. I always get some people that leave one of these x's as x. You know what x is. Everywhere you see x, it now becomes 2. Notice how when I plug something in, a value in, I put it in parentheses. That'll maintain the operations. Did the same thing over there. Maintain the operations. People will just plug them in, and then it looks like they're multiplying. They're supposed to be doing something else. You gotta be careful. So here, what do I do first?
Exponent.
Beautiful. Not 6 squared.
Right, it's
3 times 4 is 12.
Right. 1 is 4 plus 4 plus 5.
Cool.